Hi, welcome back to the channel. So in this video we will see derivations with respect to the full wave rectifiers. Before that, we should see how the full wave rectifier look like this. If we give the AC input like this was 0 to 2 pi, we are going to get VDC like this with respect to IL. IL means load current of the load voltage, where the peak value is IM. That can be written as IL as IM sin omega t, where omega t is greater than 0, less than pi. Why we have written pi here? Only for this we are getting the output, right? So this we can consider like 1 over pi 0 to pi Im sin omega dt. So this is nothing but IL, right? So this can be written as 1 over pi. So it is Im common, take it Im out. So 0 to pi, you will get sine of omega t and it is dt. So do the integration with respect to sine. So that what is the integration of sine is minus cos, right? So for minus cos, you should apply the limits so that you will get here Im by pi, right? So take minus out. So it is cos pi minus cos 0, right? So minus Im by pi. What is cos pi? Minus 1. Here it is cos 0 minus 1. So here what you will get? Minus 2, minus into minus plus. So it is 2 Im by pi. So what it is? IDC. IDC for what rectifier? Full wave rectifier. So this is my IDC. So what is your IDC with respect to half wave rectifier? IDC with respect to half wave rectifier is IDM by pi. It is doubling. So it doubles, right? So that is a IDC. So similarly, we will see next one, that is VDC. So VDC we can write it directly here. Second one, we can write VDC. VDC as I into R. So what is I? IDC, it is RL. What is IDC? 2 Im by pi into RL. So it is VDC, right? So I'll write here IDC is 2 Im by pi. VDC is 2 Im by pi into RL, right? So we'll see this the next one, so that we'll understand what is the efficiency of full wave rectifier in detail, right? So first two we have derived average DC or DC current. Second one is DC voltage we have seen. Now we will see IRMS, that is RMS value of the current. So it is root mean square. So we should first take the root, then you should take the mean, then we should make it square, right? So third one, IRMS, root mean square current, right? So how to write this? IRMS can be written as, first you should write the root, then mean 1 by pi 0 to pi of this Im sin omega t, same dt, but we should make it as what? Square. Root, mean, and it is square. Square for this, right? So now we should solve this so that we'll get the IRMS. So here Im square is there, constant, take it out. So you will get here outside Im, and this 1 divided by pi under the square root 0 to pi of sine square omega t into dt, you will get it, right? So this is Im here. So how to solve this now? Im as it is, square root of 1 divided by pi. How to write sine square theta? 1 minus cos 2 theta divided by 2, right? So this format you should do. So how to write this? 1 minus cos 2 theta. What is theta? Omega t whole divided by 2, right? So these limits are 0 to pi. So Im under square root 1 by pi. So what is half integration with respect to half omega t is half omega t, right? 0 to pi minus, what is that, integration of cos sine 2 omega t divided by 2, right? So integration of cos we have written separately so that you will get it, and the limits are 0 to pi. Don't forget the limits. So here what you will get, Im under square root 1 by pi, right? So here one time you should apply pi by 2, other time 0, so it is like this, minus half. So what is sine pi? So whatever it is, 0, sine 0 is 0, right? So you will get like this. So here you can write Im square root of, what is square root of that, 1 divided by pi, then it is pi by 2. The rest is 0, right? So how we can write this in the best way, so that we will get it is, right, this can be written as Im square root of 1 by pi into pi by 2. So here pi and pi will cancel, so you'll end up with Im divided by square root 2. So here IRMS we are getting as Im by root 2. That is the third one. That is the RMS value of current, right? So we'll see the next one. That is with respect to power. We should see DC power and AC power. That is the fourth and fifth one. So that we'll calculate the efficiency, right? You should understand when you are taking the IDC, you should take 0 to 2 pi. Sorry, 0 when you are taking with respect to half a rectifier, 0 to 2 pi. When it is with respect to full rectifier, it is 0 to pi. That is the difference, right? So that is making much of the difference here, so that you will write the correct one. That is the only difference, so that you will get a different answers. That's what I am saying, 0 to pi. Then with respect to fourth one, DC power output is DC power, right? So I should write it as PDC. So how we can write the relationship between I and R? I square into R. What is I here? DC. What is the value of IDC? We got that. That is 2 Im by pi square into R. R means RL. So it is what? 4 Im square divided by pi square into RL. So it is PDC. Right? So what is PDC? 4 Im square divided by pi square into RL. So what is PAC? That is AC input power. So AC input power can be written as, so it is PAC can be written as I square RL, but in this case it is IRMS, right? What is the value of IRMS? Im by root 2. Im by root 2 square means it is Im square divided by 2 into RL. So it is PAC, right? So what is PAC? PAC is Im square by 2 into RL, right? So now the next one is very much important. That is sixth one, efficiency. Efficiency we'll write in terms of percentage. You should calculate this, right? So how to write the efficiency? So efficiency is DC output power divided by AC input power into 100. What is the DC output power? This one, 4 Im square divided by pi square into RL, whole divided by AC input power is this one, Im square divided by 2 into RL. Which are the things which will get cancelled now? RL and RL, Im square and Im square, right? The remaining are, it is denominator of denominator will come to the numerator, it becomes 8 by pi square, right? 8 by pi square, you will get it into 100. So if you solve this efficiency, what is the efficiency you will get? Efficiency of the full wave rectifier is 81.2%. You will get it. So just solve this, so you will get 81.2%. So what is the efficiency? Efficiency with respect to full wave rectifier is 81.2, right? So this is the derivations of full wave rectifiers up to efficiency. Ripple factor is there, that I will make separate video. Okay. So now we can compare. What is the efficiency of half wave rectifier? In the previous video we have solved 40.6%. Now what is the efficiency? 81.2%. Means it is doubling. That's why it is full wave. It is half wave, right? So this is, most of the time they will ask, derive the efficiency of half wave rectifier and full wave rectifier. So this is how, if it is full wave rectifier efficiency they are asking, you should go from 1, 2, 3, 4, 5 up to the last sixth one, right? Starting from here, it is chronology. So you can't do directly this. You should go like this so that you will solve. Thank you. In the next video, we will see a ripple factor of full wave rectifier. Stay tuned to the channel. Click on the bell icon for the next video.